let's learn new topic, which is how to find the area of segment, right? Now you must be thinking, what is segment? So let's say AB is the chord and O is the center. So if we draw the chord, right, we are going to see that circle is divided into two parts, which is this is the major part and this is minor one. So when we draw the chord, we get that circle is divided into two segments, which is major segment, bigger one, and smaller one, which is minor segment. Done? Now we are going to find the area of this segment with the help of area of sector formula. How can we do that? First of all, let's read the question. Find the area of this segment AYB. Let's write Y here. So here Y, AYB. If radius of the circle is 21 centimeter, radius is given 21 and here as well. Good. And angle AOB is equal to 120 degree. So this angle is 120 degree, right? So this information is given so far. Now how to use this information and find the area of this segment? So what I'm going to do, first of all, first I'm going to find the area of the sector in which the segment is there, right? So I will find the area of the sector. Second, afterwards you can see that I have divided into triangles, right? So I will find the area of this triangle, these two triangles, and at the end I will subtract them, right? Subtract them. So this is what I'm going to do. First of all, find the area of the sector. This complete sector you need to find the area of, that's the first step. Second, find the area of this two triangle, right? And subtract from the sector. So we'll come to know that this is the only part of the circle which is left now, which is segment, right? So let's start. First of all, we need to find the area of this segment. We should be having two information with us, which is theta, it is there 120 degree. We need radius, that is also there. So it's good. Let's find the area first of all. Let's mention the things we have. Theta is equal to 120 degree and radius 21 centimeter. Done? Now let's find the area. So area of the sector. What's the formula? Theta over 360 degree multiply by pi r square. Done? Now value of theta, we know that that is 120 degree over 360 degree multiply by pi. If nothing is given, take 22 by 7. So 22 by 7 r square, which is 21 multiply by 21. Done? 0 0 cancel, 12 ones are 12 threes are, then 3 ones are 7s are, 7 7 cancel. So what's left? 22 multiply by 21 and I can write centimeter square. Done? If you want to write here simple answer as well, product one, you can write 22 into 21 will give you 2 ones are 2, 2 twos are 4, 4 and 2 6 here and 2 twos are 4. So 462 is the answer in centimeter square. 462 centimeter square. Done? Now what's the next step? I need to find the area of these two triangles. How shall we get it? First of all, very important step it is. So are we going to find the area individually, or are we going to see that these two triangles are congruent? First of all, that's the question. Now see, observe over here that if we prove these two triangles congruent, right, then we can say that they have same area, right? So our first task is to prove that these two triangles congruent. Let's give some name over to this point that will be helpful to us. Let's say M. This point is M. This point M, right? So we have two triangles OMA and OMB. So OMA, triangle OMA, triangle OMB. We want to prove these two triangles congruent. How shall we do that? So we have 90 degree over here, right? So we can use RHS criterion. That's just an idea so far. Let's discuss. So let's use RHS. So right angle is already there, OMA and OMB. So we can write angle OMA is equal to angle OMB. Now what about the hypotenuse? Opposite to 90 degree, opposite to 90 degree. Here AO, right? Or you can write OA is equal to OB. Why am I writing equal? Can you see that OA and OB is radius? Very simple. It is radius. So I can say that OA is equal to OB. Now hypotenuse is done. What about the side? We have, now there are two sides which are left, AM and OM. AM, we don't know that it is same or not, but we know that OM is the common side. So I can write OM is equal to OM, and we can write here common side. Done? Simple. So we have proved that these two triangles are equal. Now area of those triangle is also equal. So I can write area of triangle OMA is equal to area of triangle OMB. Done? Simple. So now how to find the area of that triangle? Let's say how to find the area of only one triangle so far. So I'm going to consider the first triangle OMA. So area of triangle OMA, that is half into base into height. So half into, what is the base? AM, into height, which is OM. So we need to find the value of AM and OM. So AM is this, OM is that. Now for that we don't even have to find at least one side in a right triangle. We need to have other two sides, but here the case is completely different. We have only one side and we need to find other two sides, right? We can still do that. We have angle 120 degree. Now we proved that these two triangles are congruent, right? So can we say that this angle is 60 degree? See, I'm talking about this. Let me just make the bigger one. So OAM, I'm talking that this angle is 60 degree and this is 21 centimeter. Now can we get the value of AM and OM with the help of what? Trigonometric ratios. It relates angles with the side. That's the beauty of it. Now how can we find the value of AM? Let's start with the AM. How can we find the value of AM? So you can see that opposite to 60 degree is what? AM. So this is opposite side, this is hypotenuse, and this is adjacent, right? So adjacent, opposite, hypotenuse. These three information we have. So if we want to find the AM, which ratio am I going to use? I need to relate hypotenuse with opposite side. So that is sine. Now what's the angle there? Sine 60 degree. Sine 60 degree is equal to opposite AM over hypotenuse AO. Done. Now sine 60 degree we know root 3 by 2 is equal to AM is what? We need to find AO is what? 21. So this 21 will go into numerator. So it is 21 root 3 by 2. That's the value of AM. Now don't get afraid that why are we getting this kind of values. Don't worry, write it. We still have 1 by 2 over here. We still need to go ahead there, right? So that's done for the AM. Calculation for AM is done. Now for the OM, how can we get the value of OM? Remember, OM is adjacent, right? So for adjacent we want to relate with hypotenuse. So hypotenuse and adjacent, if we relate, that will be cos. So let's take another ratio for adjacent and hypotenuse, that is cos 60 degree. Here is equal to adjacent, which is OM, and hypotenuse, which is here AO, is going to denominator will be same in both of them. So cos 60 degree value is 1 by 2, okay. OM over AO value is 21. This 21 will go into numerator. So 21 by 2 is the value of OM. So we have the value of AM as well as OM. So let's substitute 1 by 2 multiply value of OM, that is AM, that is 21 root 3 by 2 multiply by 21 by 2. Right, so you can see that it's very complicated so far. So 21 into 21, we know that that is 441 square root of 3, denominator 8 centimeter square. Now this is the area of only one triangle. Now be careful, don't subtract directly. You can see that there are two triangles like that, not only one. So see, we find the area of only one triangle, but we need to find for the another as well. But we know that area of that second triangle is also equal to the first one. So if I want the area of this segment, let's do the calculation. Area of this segment, area of this segment is equal to, what will I write? Total. First of all, I need to talk about the whole sector, which is 462. Okay, 462 minus, how many times I will take the area of this one? 2 times, because first and second there are two triangles. So 2 multiply by 441 square root of 3 divide by 8. So here you can convert to 1s and 4s. So what's left? 462 minus 441 root 3 by 4. Then this is your answer. Here you can say centimeter square. Now there is one more step you can do over here, which is taking the common factors out. How can you identify the common factor? Here I kept 21 as it is, and here as well, see, 21 is coming in the factor. So if I take 21 common out of both of them, let's see, 21 common out, then 462, what's left? 22 minus, here 21 will be left, minus 21 over 4 centimeter square. Now you want to get the common denominator as well. So this 4 will be multiplied with this. So that will be 21 out, 22 into 4, that will give you 88 minus 21, here root 3 will be there, root 3, 21 root 3, denominator 4 centimeter square. Don't forget the root 3, I forgot actually. No worries, 22 minus 21 root 3 divided by 4. I have taken 4 is the LCM, so multiply 4. So now you can write this 4 outside as well. So this is the final area. No need to get the area into decimal form. It's very difficult to get at this point. So keep in this form fraction and square root, it will work out. Let's repeat this step. First of all, you need to find the area of the sector. Understand the step: area of the sector, then area of this two triangle, and subtraction of both of them. So you'll get the area of the segment. That's the idea. So area of the sector, it is very easy to get. So we get the area of the sector. Afterwards, we need to get the area of this two triangle. So what did I do? I reduced my effort. I proved that they are congruent, right? So all I need to do is find the area of one triangle. But when we find the area of the one triangle, we come to know that we don't have base, not even the height. So to find the base and height, we take help of trigonometric ratio, which is sine and cos. From that you can find the height and base, substitute the values and get the answer. Afterwards, to find the area of this segment, what you need to do, take the area of sector minus 2 times area of the triangle. Remember, because there are two triangles, this is the area of only one triangle. If you subtract only one time, you won't be getting the answer, right? So multiply by 2, then you do the simplification and you'll get the answer. So this is how we find the area of the segment.